All right, this tutorial is going to be a brief review of basically finding the other trig functions if you know one of the trig functions. Also, this is a bit of an extension because I'm going to extend it to the reciprocal trig functions where you probably have not used the reciprocal trig functions in the past. So before I do that, let's look at one without the reciprocal trig function. So if I know sine of theta is 4/7, find cosine of theta. All right, so if sine of theta is 4/7, we can assume this is 4, this is 7, and then I'd have to use the Pythagorean theorem to find the missing side. So I can say a squared plus 4 squared is equal to 7 squared. A squared plus 16 is equal to 49. A squared is equal to 33. I subtract 16 on both sides, so A is equal to the square root of 33. All right, cosine is adjacent over hypotenuse, so adjacent over hypotenuse, this would be equal to square root of 33 over 7. All right, so it's basically setting up a blank triangle, labeling the two sides you would know given the trig ratio, and then finding the new trig ratio. Sometimes, if they're using a reciprocal trig function, you don't have to find the other side. Most of the time, you're going to have to find the third side. So it's just practicing the Pythagorean theorem, knowing to set it up. All right, so if the cosine of theta is equal to 11/17, find secant of theta. All right, so cosine is 11/17, so 11/17. Well, secant's just the reciprocal. I shouldn't even have to set this up. It's just, it's going to be 17/11. Right, secant's the reciprocal of cosine. So that'd be an example where I don't need this side. Why find this? Right, this is the opposite. Secant doesn't use the opposite. I would have to do this if I was doing tangent, sine, if I was doing cosecant or cotangent, but I don't have to do it once they're reciprocal. And so if it's the reciprocal, I should just be able to flip it. As well as if they're asking 90 minus theta, which would be the other angle. Right, this angle up here is always 90 minus the other angle. So if they say to do that, then, you know, sine and cosine would go together. Tangent and cotangent go together. And secant and cosecant. All right, so let's look at another example. All right, so if the tangent is 4/5, find cosecant of theta. All right, so 4/5, it's opposite over adjacent. 4, that's the opposite. 5 is the adjacent side. Cosecant's the inverse of sine, so sine's usually opposite or hypotenuse. So this is going to be hypotenuse over opposite, so we will need the hypotenuse. And that's just the Pythagorean theorem, so 4 squared plus 5 squared equals c squared. 16 plus 25 is equal to c squared. 41 is c squared, so c must be the square root of 41. All right, so this would be equal to the square root of 41 over opposite, which is 4. All right, and I'm done. All right, we'll look at one more. So if I have, let's say, cotangent of theta, and I'm going to say the cotangent is, I don't know, 9/2, and I want to find the cosecant of 90 minus theta. All right, now remember these are always complementary angles, theta and this, so theta plus 90 minus theta gives you 90. All right, they like to throw that into problems. I should say theta, not 0. They like to throw that into problems, different standardized tests to know that you understand complementary angles. All right, so cotangent of 9/2, well, tangent's usually opposite over adjacent, so this is adjacent over opposite. Cosecant, that goes with sine, so again, that's h/o. All right, so I will need the hypotenuse, and I need to get my labels appropriately labeled. All right, so adjacent would be 9, opposite is 2. So I already know this is something over 2. All right, and then it's Pythagorean theorem. So 2 squared plus 9 squared equals c squared. So 4 plus 81, c squared. 85 is c squared. So this is the square root of 85. Wait, not so fast. They didn't ask it for 90 minus theta, which means it's actually the reciprocal of this. All right. I'll show you what I mean in a second. All right. We're using this angle up here. Right, hypotenuse is still root 85, but the opposite's actually 9. So it's going to be root 85 over 9. Right, so they refer to a different angle. Sometimes they do it with alpha and beta and it's labeled in a diagram, but you just got to pay attention to which angle they're referring to. All right, so this is just a review as well as an extension to the other 3 trig functions of how to find the trig ratio between 2 sides given knowing only one of them. And essentially it boils down to using the Pythagorean theorem.